Hello, and welcome to this video introduction to the essay on everyday uses of the scientific method. So what I want you to start thinking about, again, as we're kind of approaching this concept of science and ethics, is this idea that scientists aren't somebody kind of sitting up in some ivory tower. We're, fellow citizens, you'll see us in the grocery store, you'll pass us on the street. And we're not wearing lab coats and goggles and safety gear and gloves and all of that stuff. Most of us are normal human beings. And so what I want you to do is think about how scientists think scientifically. And I'm going to make the argument that whether we want to admit it or not, many of us are using kind of a scientific approach as we go through our daily lives. And to be honest, many of us are using the scientific method, even though we may not necessarily be calling it that. And so again, kind of as a quick reminder, remember that science is an approach of looking at the world around us. We're going to be, kind of making observations and learning about the world around us to try to explain what's going to be going on. And the concept of science is basically on this idea that things are going to be predictable and quantifiable. So things are going to be happening for a reason. If we take a look in the morning and we look to the east, and I'm looking in the wrong direction, but my window is to the west, we can see the sun rising, and we know that that's going to be predictable. We may have cloud cover, so we don't see it rising, but we know that it's going to be there. We know that the sun is going to rise in the east today. It's going to rise in the east tomorrow, and hopefully thousands and thousands and thousands of years from now, it is still going to be rising in the east. And so that's the way that scientists approach the life. The approach to understanding the world around us is that if we understand it, we can make predictions and we can test them. And if the predictions work out, we have a pretty good idea about how things are going to be working. Now, the way that we're going to be doing that is through the process of scientific method. And so that sounds scary. Scientists do scientific method, but maybe I'm not a scientist. Maybe you're not I'm a scientist, but maybe you're not a scientist. So what does that mean? So keep in mind that scientific method is a way of collecting observations, making kind of guesses about what's going on, educated guesses, which we're going to call hypotheses, and then you kind of test it. I think the sun is going to rise in the east. So tomorrow morning, I'm going to get up very, very early and take a look in the east, and lo and behold, there comes the sun. The sun will come up tomorrow. Songs say that as well. And so basically, through the process of this scientific method, we're going to test some things, and if it doesn't work out right, then we are going to do the process of self-correction and come up with a better explanation. But it can't be subjective. The sun is going to rise up in the east because I like it rising in the east. My living room kind of faces towards the east, so I can sit in the living room, drink a cup of coffee, listen to the morning news, and see the sun rising kind of over the horizon out my main picture window. And it shouldn't matter whether my picture window is here within the Lehigh Valley, an hour north of Philadelphia, or if we're living in Australia or South Africa or some other region within the world. It's going to be reproducible, and it's not dependent upon who we are or where we are. So I said, we're going to talk about the scientific method. And so a generic scientific method is kind of a flow chart. It's going to be a process that's going to be occurring that you're going to kind of cycle around. And so you're going to start out with kind of a simple observation and say, hey, I'm interested in that. I got a question about what is going to be going on. And so for scientists, they're going to research a little bit more information about it. What have others thought about it? What have others written about it? What have others tested about it and documented about it? And then based on that information, we're going to make our guess. We're going to make our hypothesis, an informed kind of prediction about what's going to be occurring. I think this is going to be how things happen, and that is going to be my hypothesis. That is going to be my explanation that I'm going to be testing to try to determine whether or not it's true. We're going to test that with an experiment. So we're basically saying, does my explanation work under this situation? Does my explanation work under some other situation? We're going to take a look at that. We're going to analyze the data and say, did it work or did it not work? And then determine the conclusions. Now, if it didn't work, we're going to try again and come up with a better explanation. If it did work, that doesn't mean we're right. It just means that we're supported. And we potentially have to test it a little bit more to come up with an even better, more complete explanation. So the goal then is, for me, as the instructor in this course, to convince you that you use the scientific method pretty much day in and day out without ever realizing it. So we're going to attempt to apply it, but these terms, hypotheses and analysis and experiment, conclusions, research, those can be scary terms, especially for non-scientists. And so how can we use this scientific method if there are a bunch of scary words associated with it? And so what we're going to start out with is this concept that in the process of troubleshooting, when you kind of come up with a problem that you need to correct and address in your life, you're going to probably try to come up with your solution using the scientific method. And so when we do this, instead of, let me back up a second, instead of looking at observations or questions, what we're going to do is define the problem. And so in this case, I've got a problem. I've got a lamp here in my office at home. It's not working. That's not good. I've got a bunch of other lights because I'm recording right now. But I want this light to work because it's my favorite lamp. I want it to work. I'm not sure why it's my favorite lamp, but it's not working. So I've got to try to figure out what's going to be going on. So my problem is my lamp is not lighting. So I'm going to collect some relevant information. This could be, coming up with the user manual, going on Google and saying, why doesn't my lamp work? Or, kind of coming up with important information later. Asking somebody, call my dad and say, Dad, my lamp's not working. Why is that? So we're going to collect some information and then we're going to try to apply it. And so we're going to propose a solution. So if your lamp's not working, maybe it's not plugged in. And so what we need to do, determine whether or not it's plugged in. And so how are we going to do that? We're going to test it with an experiment. We're going to look down and say, okay, let me dive down for a minute. It's plugged in. It's plugged into a power strip with other things kind of running for this recording. So that's a situation where we tested it. Is it the fact that this is not plugged in? Did it fix the problem? No. Okay. That's not good. And so in that case, the answer is no. So we got to collect additional information. Maybe something else is going on. And so take a look at it. Okay, in this case, maybe the light bulb's burned out. So we are going to propose another solution. We're going to change the light bulb. So take that light bulb out, pull up another light bulb, plug it, screw it in, and lo and behold, and I continue to turn this off, my light works. Now in this case, I use the troubleshooting method, applying this scientific method to come up with a solution to my problem as to whether or not my lamp was working. Now in this situation, I ran one experiment. I tested the plug. It was plugged in, so that wasn't the solution to it. So I had to come up with another solution. I needed to change the light bulb, and in that case, change the light bulb, fix the problem, and now my favorite lamp will light, and I'm very, very happy. And so, what is it that I want you to do to think about applications of this troubleshooting method, which we're going to call the scientific method because we are, in a science and ethics course. So what I want you to do in this case, yes, we're going to report the conclusions. Yay, my light now works. Everything is good. And so we're going to implement the solution, leave the light bulb in there. I'm not going to replace it with the burned out light bulb. This will go, in the trash and be disposed of. So what I want you to do is think about in an essay, so a relatively short kind of written assignment, how would you apply the scientific method? So I want you to consider a situation where something you need stops working. So an example of that is you're driving your car. Hopefully your car doesn't look like the example over here on the left. The engine stops running. That's not good. You need your car to get places. You need your car to get to work, to get to school, to get home. What are you going to do to try to figure out what is it that is causing your car not to run? Maybe it's that your computer stops working. And again, I don't understand a whole lot about the computers. I'm getting old. Used to know all that stuff pretty well. But what are you going to do to determine how you're going to fix your computer before you go, and take your computer to a computer repair shop? Similarly, if your car, stops running, what are you going to do before, you have it towed to a mechanic for them to take a look at it? Now, I'm giving you a couple examples. We did this assignment in previous semesters, and we talked about the cars, but I got a lot of responses that people don't understand how the car is working, don't do that type of troubleshooting, and I can understand that. I grew up on a farm, or grew up working on a farm, lived next door to a farm, and so spent a lot of time keeping things running and doing that. So that was kind of natural to me, but not necessarily natural to some other people. So maybe a lamp, that's not a good example because we did that one here, but how is it that you're going to apply the scientific method to figure out what is wrong with something that's not working for you? So what I want you to do, write a relatively short essay, 250 to 500 words, roughly 1 to 2 pages. I'm not necessarily worried about word limits or page limits. Tell your story. Don't pad it, but also don't have it being artificially short. So describe how it is that you would use a scientific method to determine what your car or your computer or something else to stop working. Provide ideally 2 or 3 hypotheses, which, we're not going to use the term hypotheses because we're trying to make this user-friendly. 2 or 3 reasons or 2 or 3 explanations about what is wrong, and then describe the kind of experiment or describe the solution that you would use to try to fix your car, your computer, or your something else to make it accessible and available to you. So again, not meant to be an onerous assignment, causing you lots of difficulty and lots of research, but just basically think about what's something that you've been faced with that isn't working properly, and what were the steps, what were the processes that you used to try to fix it before you, kind of threw it out and replaced it, or took it to kind of a professional like a mechanic or a computer repair shop in order for them to fix it for you. So as always, I'm available to you at any point. Please feel free to email me. I am here to help you be successful this semester. So if you've got any questions or concerns, please do not hesitate to reach out to me. So thank you and have a great week.